Hello everyone, in this video we will quickly revise the complete chapter of real numbers. Let's begin. In this chapter we will understand real numbers, Euclid division lemma, fundamental theorem of arithmetic, HCF and LCM, irrational numbers and decimal expansions. Chapter summary. Introduction to real numbers. Real numbers are all the numbers that can be shown on a number line. They include both rational numbers like 1, 3 by 4 and 0.5 as well as irrational numbers like root 2 and pi. Here you can see a flow chart where real numbers has two parts, rational numbers and irrational number. Rational number has integers, whole numbers, natural numbers 1 to 3, 4 and so on. Irrational number root 2, root 3, pi, root 5 and so on. Now here comes Euclid division lemma. Divide 23 chocolates among 5 students. 23 equal 5 multiplied by 4 plus 3. Dividend equal divisor into quotient plus remainder. Each gets 4 chocolates and 3 remains left. Now Euclid division lemma tells us whether we divide one number by another, we get a quotient and a remainder. Relations dividend equals divisor multiplied by quotient plus remainder. And this concept is mainly used to find HCF of numbers. Now comes Euclid algorithm to find HCF. HCF of 36 and 24. Draw a rectangle of 36 by 24. Cut the largest possible squares. The side of the largest square that fits exactly is 12. So HCF is 12. Now comes fundamental theorem of arithmetic. This theorem states that every composite number can be expressed as a product of prime numbers in a unique way. For example, 60 can be written as 2 multiplied by 2 multiplied by 3 multiplied by 5. This theorem helps in finding HCF, LCM and proving irrational numbers. Here you can see we have factorized 60. So 6 and 10 are two factors where 6 can be written as 2 and 3. 2 multiplied by 3 and 10 can be written as 2 multiplied by 5. To find HCF, we take the common prime factors with the smallest power. To find LCM, we take all prime factors with the greatest power. Prime factorization make this calculation much easier. Now comes irrational number. Irrational numbers are the numbers that cannot be written in the form p by q, where q is not 0. Examples include root 2, root 3. Their decimal expansion never end and never repeat. Decimal expansion of rational number. When we divide a rational number and write the answer in decimal form, it is called its decimal expansion. For example, 1 by 2 equals 0.5 and 1 by 3 equals 0.3333 and so on. Terminating decimal expansion ends after a finite number of digits. Example 0.5, 0.75. Non-terminating recurring decimal expansion continues forever but follows a repeating pattern 0.33, 0.2727. Now an important rule, if the denominator of a rational number contains only prime factors 2 and 5, the decimal expansion terminates. If it contains any other prime factor, the decimal expansion becomes non-terminating but recurring. Quick summary, let's quickly revise. Real numbers include rational and irrational number. Euclid lemma helps in finding HCF. Fundamental theorem of arithmetic gives unique prime factorization, have either terminating or non-recurring. Thank you for watching and don't forget to like, share and subscribe.